Section 9.1, Sample Means of Random Samples. So I want to bring your attention to the keyword means. That's the difference between the chapter 7 and 8 material and the chapters 9 and 11 material, is that we have now switched our focus from proportions to means. So we're going to have some different terminology, some different symbols, some different StatCrunch commands. Even though the overall ideas are the same, because of the switch in the actual values that we're talking about, it's going to cause some changes in our work. Okay, so our first statement here is that the sample mean, and that is symboled with X bar. So that's similar to a P hat, like it's kind of similar to that. This is the new version. The sample proportion was P hat, the sample mean is X bar. That sample mean is an unbiased estimator for the population mean, which is symboled with a mu. It's a Greek letter mu. So again, that's sort of like the P from last chapter. New symbols, they're standing for different things. If we took multiple samples of the same size, what will happen is that the mean of the sample means will be the same as the population mean. That's a bit of a confusing statement, so I want to give you an animation to help you understand what that's saying. The mean of the sample means is the same as the population mean. Okay, so if we look at this website, it allows us to take a population. So I've got a random population created above. Doesn't really matter what the parent population looks like, and you can't really control that. But what it's saying is if I were to take many samples, so I have it set on samples of size 5. So what if I take a sample of size 5 out of that, and then I drop down the mean of that sample? So for those 5 data points, I calculate up the average. What if I graph all of the averages of the different samples that I take? So I take another random sample of 5 and I drop its average down. And another one, and its mean, and another one, and another one, and another one. And instead of doing this over and over again, I'm just going to skip and I'm going to say, do this 10,000 times. Okay, here's what that statement is telling us. Look at the blue graph and off to the side, look at its mean. The mean of the sample means is 14.54. And that is a pretty darn good estimate for the mean of the whole population, which was 14.5. And the more that you do this, if I do this 100,000 more times, it should get even more accurate, and it did. So 14.51 is an even better estimate for 14.5. So that's what this is saying. It's saying if you take lots of different samples and you calculate up the mean of each one of those samples, that should give you basically the mean of your whole population. We have a new formula for standard error in this unit. So when we take the standard error of sample means, we do the standard deviation divided by the square root of the sample size. What we already know from the prior unit, again, the overall idea doesn't change even though some of our formulas and symbols do. The overall idea is that the more observations that we collect, the more precise the sample mean should become. And the more observations we collect, the smaller the standard error should be. Right? Bigger samples give less margin of error. We've switched gears though, so again, we're talking about means. Our formula has changed. You should have both of these memorized for the final test and for the final exam in this class. So our old formula, again, don't forget it, but we're not going to be using it right now. The standard error for proportions was that square root of p times 1 minus p over n. We used that all in chapters 7 and 8. When we're in chapter 9 and 11 material, we're going to be doing standard error for means, And it just changed the formula that we need to use. We need to use the standard deviation over the square root of n. Of course, it wouldn't make any sense to use p's in a formula for means, because p's stand for percentages, and we're not talking about percentages anymore. So the formulas have necessarily changed a bit. So just again, as a reminder, our symbols are changing. The symbols we're going to use in our formulas and in our write-ups are going to change. The sample mean is symbolized with x bar. That's similar to the sample proportion, which was p hat. That's like the equivalent in this unit. And the population mean is symboled with mu, whereas our population proportion from last unit was regular p. So we've made some symbolism changes, we're making some word changes.